Vector to string. Maybe I should have it linked to my machine over NFS. Because that cache of them is not working. It keeps rebuilding guitars over and over and over. That's not really caching. I think you can run this thing also what I call locally. Maybe in that case the whole container is actually locally. That might be interesting as well. Maybe I should have a look at that. Hyperplane test paused. Yeah, well, I'm hoping for a bug, but I suppose it doesn't have a bug then. Quite curious what it is generating at the moment. Add emoji prefixes for testing. What? Oh, these things, yeah. Yeah, might as well get it locally. And now we can have a quick look here at executable math hyperplane tests. Math hyperplane test.cxx. Target link libraries, math hyperplane test, AI, cxx, math. Well, that's the same as that one. I can't complain about that, I suppose. Even the same as that one. We need eigen here, yeah. Yeah, the same as this. Okay, and then it has a sys.h as first header. Wow, did it run into a compile error that added it, or did it add it right away? It has not added debug output apparently. I'm not sure. Well, there is no debug.h here anyway included. We have a tolerance again. We have the coordinates that I suggested. Okay, signed distances. Bunch of distances to test. the require and require near. Make a 0, now we should make a 0 vector. Generate vectors. I'm gonna go over it real quick. Normalized description vector to string. Require vector near, find tangent, run dimension tests, lots of tests. Main driver dimension test class expression. Yep, that's a false. If I told it to not run these tests because that might take too much CPU and stuff. Okay, so we can do create pull request. And then we go there. And then there's a nice commit message with a link to the, well, yeah, conversation, I don't know, that where it did the task. And yeah, I'm just gonna click merge pull request. And then you can see here, it's open, and now it's merged. So this was the first one, I just figured out how to do that. And I can go locally and do a git pull. Yep, and then we do yeah, just make, I suppose. That is configuration. I don't think it compiled the new. Do I even have the new file? Yeah, I have it. Did that get compiled? Well, anyhow, I need to add that, or does it automatically get added, or everything gets added? I can do a resource. No, we have an alias. Yep. I don't know where, but it's sneakily compiled it apparently. Now it would be nice, I think, if on my machine it automatically would compile the other stuff. So instead of testing this, I'm just gonna test let's not do this. Let's just set let's test an environment variable. Do a long tests, or are they long? I don't know. I don't know. Hello, Alican. Okay, we could just do this as well, it seems, yes. Get inf. I suppose that what kind of environment variables do I have that Codex won't have, doesn't have? Well, like, a lot of them, I think. Mostly functions though. I have one that is called a maintainer, I think. Nope. Suppose that standard getinf also exists. Let's make sure of that and look for the header. See standard lib, obviously. Notes if, then it exists. Yep. See, I don't see a C standard lib. Could use this, but Codex does not have that set. Prompt command, repo base. I think I actually set that in the environment of. Yeah, okay. Good enough. That definitely did run longer, so that part worked. And not insanely long either. Let's see if it did what I said, what I asked. It runs it for dimensions 2 and 3 and then also 4 and 7 in my case. Yeah, I want debug output, come on. So debug, namespace debug init. And then we can say here, I know for sure that it runs. Running I should just print that inside of a dot function, otherwise I do it 4 times. Generate vectors to generate a bunch of normals. That is being done as follows. Vectors is the result. Combinations 1 for I 0 and runs over all dimensions. Combinations is multiplied by the size of k coordinates. Reserve combinations. So it did not do any restriction there. It's kind of weird. It should have been much slower then, I think. But well, it's still just all. So with 7 dimensions, you have like 7 million vectors. This way. So if it now is it going to restrict us to just using the first view? Then we'll only have these coordinates, not as much as 0, or let alone positive ones. Yeah, guess it doesn't really matter. I think, however, I should print the output instead of looking at this code. I suppose the code works, but you see, reserve, run over all the number of combinations that we have. Vector type, candidate, make 0. All 0 is true. Dimensions. Over all dimensions, value is k coordinates remainder mod k coordinates size. Not exclude 0. Or not all 0. Let's print what is this? The out DC notice, comma, all normals all equals normals all. That's serious. You want to be able to print that. Probably can't. No, wait a minute. This definitely won't work. How about that? A lot of output. Okay, I'm so not happy with how it prints a vector. Let's begin with fixing that. I think the vector type here is just math vector. Which is a print on. I'm just printing v underscore, which is a eigen type, but nah, not working for me. So instead, we'll just run over all the elements. I think it has a size. The eigen type, eigen matrix, yeah, must have a size, doesn't it? Oh, just n. Branch tree, shit. I never tested if it is faster with the branch. Probably not. It is a lot. Not gigabytes though. So for 2 dimensions we have normals is this vector, which exists of a vector with twice the same coordinate, -7.89. And then the first one changes and the second one keeps like that, and then we go to -2, -1, 0, 1, 2 and 8 point something. And then we go back to this one, and now that one is -3.1415. And so that totally works. Yes. And it does skip 0, 0. Because you don't want to have that as a normal. It wisely concluded, the AI. And then of course for 3 dimensions we have 3 of those beasts, which iterate over every possible combination. All the way up till, oops. One, two, three, 4. Three. This is 3. 1, 2, 3. These lines are too long. Now, anyway, that seems to work, right? Yes, totally. Let's print. Was it all? Let's print point as well. Yeah, the actually point is just exactly the same as normals. Haha. Except that now the 0 should be included. Totally believe that works. Apparently I don't believe it. It's a good thing I didn't believe it, because it's still skipping 0. What? That too. Something is not right there. So point, oh, because I'm still printing normals, I'm such stupid. So yeah, now it works. Okay. Have that as well. Totally works. I didn't say anything. Max normals if n is 264, otherwise 100. What? That's why it's so fast. Of the 2 million, it only uses 128. Select subsets. Yeah, see, it only pushes back source index, where index is just running the 0. So it only takes the first things. That's not random enough. If you only pick 128 of a 2 million list and you only pick the first ones, come on, that's horrible. What is a better way to do this? Well, for sure, a better way is to increment the source faster. So index itself should grow faster. You have a size and a maximum. So the step size should be more or less. It does have a step here. I'm not looking correct. Oh, it does step. Oh, it does step. I wanted to implement the same thing. Yeah, so step is the source size divided by the maximum. And then the cursor is incremented by the step. Yeah, that's not really necessary to use double. Like, no way. I mean, you divide by something that is most definitely, well, it's 128, say. This is a size type, so this is less than a size type. It just fits in a size type. Probably the same result, but, well, choose a size type here. Did it use step itself was a double, right? Maybe it is correct actually. Oops. Oh yeah, okay. Step itself is a double. It's fractional, I mean. Yeah, okay, yeah. That should never happen. Okay, not so bad after all. I think you can keep this. No, it's really going to take a long time. Really going to take a long time. It's a bit too defensive. It should just never happen. I already have the requirement here. Don't need my assert. Does my vector type not have a way to normalize itself? Maybe we should add that. I think it doesn't. Well, that would be a direction actually. And you could call direction. And then I get a yeah, same thing I guess. Not sure why this is being used. Might I'll just call that just divide by the norm instead of call normalized. I mean, this checks that the norm is not 0, but hey, it would just crash anyway. Plus, it should never be 0 because we don't have that in the array because false is being passed, true is being passed. I mean. Let's change this to normal divided by the normal norm. I'm wondering if it is not faster to make a copy and then do it, or well, this creates a copy of normal, or temporary, I mean, and then divides it. Ugh, how does that work? Let's have a look. So make a copy use the copy constructor, and then it is divided. So that would be the operator. This operator. And then we construct. Okay, so we do this, from which you destructed temporary, which then is just put back into this vector here. Okay, so probably good enough. Point index base point of all point is a b is a minus the normal dot of the base point. Create a hyperplane. Context description in normal index point index base checks. Well, that makes it slow. How about we don't do that until we actually crash on something. There's a lot of string manipulations. I'm shocked that it would return in plane for all the time. I mean, so no floating point around of error here. Oh, it is an absolute relative error of 1/millionth. Yeah, that's okay. Definitely should be in plane indeed. Require a vector near plane project base point near base point. So we do have a project. Orthogonal projection of A onto the plane. Origin projection. Project 0. Expected origin projection. Should have gotten that from the comments, I think. You have a vector. You have a lot of comments here. I wrote a lot of comments. I did not write a lot of comments here. No, I wrote a lot of comments here. Hyperplane. Origin projection. Well, find that back. It's called Q here, clearly. Yeah, does it say? Q is row dot the unit normal. And what is row then? I think row is just minus b. Trying to find that quickly back. That's not. Well, for arbitrary n, we have row is minus b divided by the norm of the normal. And then that must be multiplied of, yeah, it's just a normal multiplication here because row is a scale. So that must be multiplied with the unit normal. Minus b divided by the length of n times the unit normal. That would be the projection of the origin on the hyperplane. And it multiplies with the normal, but then divides by the length. An extra one. So we divide here by the normal norm, indeed. Minus b divided by the normal norm, and then times the normal divided by the normal norm. Because it is squared. Yeah, I'm totally happy with that. Origin projection should be near the expected origin projection. Require near plane signed distance of the origin projection must of course be 0. Tangents, find tangents. Normal and points all. What the hell is find tangents? think this calculates a projection of all candidates onto the hyperplane. And then returns the first one that has a non-zero length. The I can't type problem. Doe met je functie recall to standard vector math vector 2 standard int. Why don't you say that immediately? Holy fast. How is that so fast? That is insanely fast. I want deep output. Now I got it on sneeze. This is slow. If 3 was already so slow, then 7 is never going to finish. Well, actually, yeah, just limited it. I think 7 is going to be as fast as 4. It might be 7-dimensional, but it's just limited to 1000 vectors. Doesn't really matter. Yay. Cool. Now that worked. Okay, git diff. The next step then is to also move a hyperblock to math, because we don't have that yet. So if we go to math, now we have a hyperplane, no hyperblock. I think hyperblock is still here. Was it in cairowindow? I thought it was in cairowindow. Don't see it. F A capital. I don't see hyper. Hi array. Struct hyperblock. Yeah, it's in intersection points. Totally true. Okay, so I push like crazy here. Let's update this. Let's update transform with all the latest Git submodules. Okay. Did I get the latest Kitash now or not? We think. Yeah, well, I think I got that because Kitash is just in Kitash. ls opt Kitash. I mean, that's where it is. So every project gets the same version, and I already manually updated it. For another project. Yeah, can I still compile this? we can I still run something like, what is the last thing that I was working on? I don't know. We have a trick for that. ls alt ltr. Coordinate system, what age is the last one? Maybe hypercube. Kind of makes sense, I guess. Yep. So there's a bug because this should be 140. You have a 7-dimensional hyperblock here. It's like a hypercube, but then with different sides, and then all the sides are the same. So it's a hypercube actually, an n cube. And the 3.5 here, well, that's the half of 7, which means that I think we cut it with a plane, like symmetrically through. I'm not sure anymore, of course. Maybe I should make 100% sure, like 100% sure. Otherwise, I'm chasing a bug that doesn't exist. Although I have to move hyperblock anyway. Let's just, I don't know, hypercube. Where did I get that from? Or that was from cairowindow. Find name hypercube. It's not there. CPP. It is there. It is in source even. Yeah, see a tiny little program. So the hypercube is actually, it's hyperblock. It's called hypercube even. Has 2 points, 2 corners. The origin and the point at 7 ones. And then of course all the other points. Just every coordinate can be either a 0 or a 1. So you have 2 to the power 7 points here, which are the 2 to the power 7 corners of the cube. And then I have a hyperplane with as a normal vector all ones, which is obviously the vector from this corner to that far corner. And that is the normal, right? So think about a cube, a normal cube. We just have a plane that is perpendicular to one of the long diagonals. And then depending on where we put the hyperplane, if you shift it along this long diagonal and you shift it all the way into the origin corner or even beyond that, then you don't have any intersection points. The plane does not intersect the cube. Likewise, if you move it all the way to past the other corner, also no intersection points. If you don't move it entirely beyond these points, then the number of intersections is equal to, well, the number of dimensions, because each corner has this number of edges connected, 7 in this case. But what I want to do is put it exactly in the middle. So the big question is, of course, then, what is this? What is this? Well, this should be, oh, there we go. I think it should be minus 3.5. I'm pretty sure that the documentation is not correct. It should be minus some point in the hyperplane dot product the normal that you pass. Yep. B must be the negative of the normal dot P for some P in the plane. And of course we're going to use the center point of the hypercube, which is a half, a half, a half, a half, a half, a half, a half. And if you take the dot product of that with the normal, which is this one, you get 1 times a half plus 1 times a half plus 1 times a half, and so on is 3.5. And we're totally missing the minus sign. So maybe you don't have a bug. Hypercube, 140, 17, still a bug. Yeah, now we've thought about it. Yeah, the dot product of this normal with the center point of the cube. That must be halfway, obviously. That is 7 times a half is 3.5. The minus sign in front of it. Yeah, totally. Totally not correct. Okay, I'm gonna move it to the math submodule, and then I'm going to have the AI write a test suite for this one as well. So we just updated math. Call this math. Let's have a look in math. Hyperplane for inspiration, and then I'm going to copy from the cairowindow Hyperblock. And where was the last time I saw that? A long time ago. No, don't see it anymore. Well, I can't remember it anymore. Intersection points. Now I remember it. Intersection points. And then we're going to create a hyper, and I make that a lowercase as well. I just define here in the new words for the dictionary, hyperblock. It's one word, as of now. I mean, hyperplane is. Apparently. Okay, the inspiration is that we need pragma once, and then probably include the hyperplane, I think. And we do work in math. Next. No, what? Copy this. Next. This is where I want to copy it from, but do next and then paste it in here. Close the namespace. Hyperblock. Okay, can I start here? What is in front of this? This is corner. Yeah, we don't want to copy that just yet. Maybe I have to. Where's corner even used? I have a corner index. Ouch. Oh, that's a small thing. I have a side. Corner. Oh my god, I have a corner. So corner is needed for the hyperblock. Well, maybe it's just corner. What is this? Let's comment that out. Oh yeah, that was the old vector. No longer need use that. I now use math vector. And what the hell is value type? Don't use the most significant bit. That is a value type. Okay, value type is also used. Corner to be used as index into hyperblock array. And side. Maybe you need to copy side as well. So for context, let's go to see what this was. Hyperblock capital C underscore. That is a vector with all 2 to the power n corners of the hyperblock. And we probably run over all of them quite often. So yeah, you don't want to have too many of them. Like not, you don't have 2 billion of them. That's just, no. I mean, we're working in higher dimensions, but 100 dimensions is already not going to happen. Wait a minute, 2 to the power 100. Yeah, definitely not going to happen. Let's not go beyond 30 dimensions. It's also ridiculous. N is just small, like 2, 3, maybe 4, and then 7 on a crazy day. But yeah, you gotta stay serious with this class, I think. Must fit in your memory and stuff. So a 32-bit integer is large enough because, well, loop over that. That's already 4 billion or 2 billion without the sign bit. You don't want anything larger. And it is kind of then the value type. I'm totally wrong, am I not? See, this is so confusing. Value type is 32 bits, but what does it mean? Value type. To be used as index into blah blah blah. Yeah, okay. Definitely an index type, maybe. I should call it index type. Corner index type even. The weird thing is, however, that I have a corner index here. So what is the difference between this one and that one? Because this one is called index into an array with corners. Yep, so this is an array or vector that uses the type corner index as the index type for its operator square brackets. And then I have another type which mirrors that. Why am I using value type? That's a good question. Yes, I wrote it, but it was several days ago, so it's like new code now to me. Value type, value type, value type. You get the value type by calling value, and that's the only place where I ever use this. So who's going to call value and what are we doing with it? Value is being called here, and it's printed, who cares? It's called here, which is just converting it back somehow into a corner index. Okay, ORing it with a bit here. That is... yeah, that's how you build the corners. A corner is like has coordinates like 0 or 1 for each dimension. So it could be, the corner could be 1 0 0 1 1 1 0 1, right? And they can read that as a binary number and then interpret it as a integer and then say, but we know which corner it is. That's the corner with coordinates 0 1 1 0 1 1 0 1 or whatever I just said. And then if you want to flip a certain dimension, then you just shift 1 that many places and you flip then that bit and then you get the index of the corner on the opposite side of that axis. That's how we work, and I guess that I'm even looking at the wrong line here, because this is not value, this is get value. CI is already corner index. But same story. I do have a value though. No, we don't have a value. You gotta be kidding me. Oh, here's a value. Yeah, but then it's just printing it. No, ridiculous. Because I'm not using it yet. Who the hell is using this? Let's comment it out. Maybe it's not used at all. Yeah, apart from the printing thing. See, that is what I call suspicious. It is not used at all. If that's not used, then the corner object itself is not useful. It's just a wrap around something that is not used. So then why am I using the class corner already in my hyperblock? Here, return the distance from the corner to the hyperplane. Okay, now the hyperblock itself knows what corner index is, and apparently it does not need to know anything about corner. I'm just gonna pass corner index here. Good, so now I don't need corner anymore, but we do need the corner index, where it currently uses class corner as category, but I can also change that. I'm going to, don't need the value type either, I just need this. Let's copy this, and then we go to, there's only one file to edit. Okay, let's quit. Now I have a math corner index and a math hyperblock, assuming I'll fix this. And then here I deleted hyperblock. And I should also delete the corner index. And then we need to include the hyperblock for math. Okay, let's do that. Let's add it here as well. Keep typing black. It's on the other side of the keyboard. I've been doing chess too much, I think. It's in my spine. If I type black. Black and white. Beep beep beep. Let's see. Block, so that should now work because I just included it in this namespace. Although it's called Hyperblock here, and I removed that capital B to let you file-wide substitution with a lowercase b. And the corner index, yeah, it is used a lot. While I'm at it, let's just do using this here as well. Corner index. Now it should compile again, even despite the move to this file. I need a utils vector index though, which is from utils vector index. So surprisingly, I could never have guessed that. Include the standard floating point. Where the hell does that come from? Concepts? Probably concepts. I'm gonna look it up. Totally concepts. Math vector, yeah, this is already included by the hyperplane. If I include hyperplane, do I need hyperplane? Yes, I need hyperplane. Well, might as well not include a vector then, but include a hyperplane. That should give me the utils. Wait, utils vector is something else. That should give me the math vector. Also need a utils vector. Do I need to include both? Unlikely. Utils vector, math vector, source vector, utils vector. That utils vector includes vector index already. Okay, so you can delete that one then. Standard vector and print on. Yeah, we have a print on already in Hyperplane, so that should be already be taken care of. And maybe standard vector as well. So you already have a print on here, so that nothing extra needed. Math vector is included. I doubt that math vector. Find that back. Math vector. Math vector is not including standard vector. Let's include that here then, because while we use it, probably should do that anyway. Let's say Hyperplane is already including standard vector, but not 100% totally necessarily unmissable part of Hyperplane. Then we should include vector here. Anyway, ourselves, you know. But if I had a like Hyperplane, like vector, for example, if I see that utils vector includes utils vector index, then you can count on it that in a million years it's still including vector index. So we don't need to do that here. Just they just go together. Yeah, that should also already be known then. Or does it? No, this was especially needed, the prelude here, because C is an array or a vector or something like that. Let's look at Hyperplane again. Hyperplane, see, it does not have the prelude, so it is not necessarily supported in here. The prelude is defined in CWDS debug. Okay, well, we totally have that. We have that. Of course, I include we don't have that. That's why we need. I mean, that's what I was saying. That's why we need debug.h to have that macro defined. This comes from the command line. That it's not related. I think I have everything now. You know, it might just compile. Did you mean Hyperblock? No, I did not. Hyperblock declared here. Yeah, for declaration. What? Percentage S. Did not rename that here apparently. Cannot define or redeclare intersection points here because namespace intersections does not enclose namespace hyperblock. I think we have to move more. That is line 211. 211. Aha, definitions of hyperblock. Printer. And that's the last thing. That had to be moved here as well. That defines intersection points, right? Oops, now we have math sign. Oh, but it is math sign is already here. This is in math, yeah. Literally like. It's part of Hyperblock. Well, it's defined in hyperblock.h. So we have sign. We have corner index, obviously. What else? Debug.h. Yeah, positive, and in positive is like a really general name to have laying around in this namespace, I think. But this is now math already, so I'm not going to Repeat that. Yeah, that was for printer in corner. Okay, maybe you still need that then. What was it called? Include cairowindow intersections or something like that. Intersection points. And maybe not. Then what is it? Damn it. Maybe a can't type. I can't type. What is different? Intersections. Amazing. There's more that doesn't work. This is now called math and lowercase b. I have the feeling that maybe we don't need this here then. Let's just try not to include it. Math Hyperblock. Wait a minute, I should reverse those two arguments as well, should I not? Hyperblock. Yeah, well, for one thing, this is math. Hyperblock with a lowercase b and QA, maxi tags, VI. Oh, float type and then the number of dimensions. Yeah, but. Why do I remember it the other way around then? Because Hyperplane was changed. Hyperplane was changed. Let's change this one as well then. But maybe not right now. Let's make it first compile. Bloody hell, it compiles. Okay. Grab sources for Hyperblock with a capital B. And it's still there. What? Commented out though. So the change here is math Hyperblock. And the other one was there, also commented out. Math Hyperblock. Totally nothing anymore. And then we look for Hyperblock. Probably should have done this one first. So this VI here is an alias to a script in my path which decodes whatever I paste here, and then opens NeoVim in a way that I end up at the correct line number. But since forever, that only works for the first file. So these line numbers here are not being used, which is very annoying. I wish I knew how to do that. Maybe I should fix it, like now or something. So this is line 165. Is that where I wanted to go? Well, probably. So I wanted to switch these two. I'm going to do that everywhere. In comma float type. Oh, and the float type should probably be renamed to T, because then I can't search for it anymore with it. Now we can do a regular expression search for float type. But yeah, I use T everywhere else now. Yeah, well, everywhere like in Hyperplane. I don't know. So this uses standard floating point concept, which I'm pretty sure I'm not using in Hyperplane. Probably should do that. Put the dots on the I, as it were. So that's all. Hello, Yuyin. Yeah, and the double becomes the default, so I can just make it the same now as the Hyperplane here. Just have a 2 for the number of dimensions. And so I'm just going to delete the double, and that should be what I want. Let's do the previous file as well. Well, there was no double here, I think. No, just float type. Next, and then the block. That's a definition of it. Oh, wait a minute. Then I have to change this as well. Hyperblock. in, comma, float type. In, comma, float type. Hyperblock. In, comma, float type. And this is the definition. It's a struct. Seriously. Wait a minute. So int n, comma, float type with as a default double. Why is this a struct? We look at the same class, and we see that it is also a struct. Blink, 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 blink. Yeah, it should be a class by now. It has been worked on and worked on and worked on. It's now mature. Gonna make both classes. Go back a T here. And then the rest also as well. So substitute float type with just T. And then in Hyperplane, this is Hyperplane. No, it's Hyperblock. T in Hyperplane, I'll also use a T. Also standard float type already. Awesome. Okay. Well, will it still compile? Nope. Hyperblock nested namespace specifier NT or declaration does not refer it into a class. Oh, there's intersection points again. No included form. Never mind. Math hyperblock. I don't know. I can't read this. I just look here. What is wrong with this? Yeah, I forgot to swap this, I guess. Forgot to swap this. Int n, comma. Let's be lazy and just wait till the next error. Hypercube double as the default. And we go to the next one. There's no next one. This was it. Well, isn't it amazing? Hyperblock. Was that a thing? It's not a thing. source. Yeah, hypercube. Oh yeah, I was testing hypercube, I think. 17, still 17, so I didn't completely screw up, but it's also still buggy. Git status cd cairowindow. I think I just removed stuff here. Git diff. Okay, so we removed stuff from intersection points.h to math hyperblock.h, which is why we included, and which is why we renamed intersections hyperblock to math hyperblock, and the double is gone, and the rest didn't change, and then we do that again, and then again includes and including classes into namespaces. Corner, what is that? No, that was also moved, and this. I don't even see the difference. There's probably no difference. How is that deleted and added? Exactly the way it is. Oh, the capital B is changed. Right. Yeah, and value wasn't used, so it's still commented out. I don't care. Hyperblock was removed from this file. Capital B. Float type and N was swapped. Oh, that should be changed back. Something with this. And that is a definition that was also stuffed. As in, we did stuff to it. Okay, let's uncomment that again. So that doesn't compile now. Wait a minute, there's no value. So that's why I needed a value, so I could print it. Ah. There's a way to get the underlying, no, it's just a size type. The underlying type of the corner index is a size type, but I don't want to use that. I want to use an uint 32-bit. I'll think about this later. Make it class, and it still compiles it. How amazing is that? And I did run this too. Of course I did. I just can't remember it anymore. Yeah, I did. Git add Hyperblock. Have a look at it anyway. Yeah, good enough. Add hyperblock. Yeah, it changed hyperplane into from a struct to a class. I'm not even going to mention it. Git push, git status, git diff, autogen. What? Why is that not automatically committed then? So confused. I don't think anyone gets happy from having to pass 2 all the time. Like all the time. Which is the majority of the diff here. Now it makes sense to use, let's say, cairowindow types. Which are just simply two-dimensional periods. And I might be in that namespace anyway here. I'm not sure. Let's have a look. Coordinate system. No, it's not in cairowindow, is it? Yeah, it's not totally not. That's transform stuff. But I can just do a using, I suppose. So let's say point, right? I mean, I have math. I have we have already a point in the current namespace, which is a template. I am using cairowindow here, but as a using thing, so I cannot do using cairowindow point, because then it will get confused with the point that I defined for in the transform. I have so many points here, vectors and lines, like every namespace has one. To spell it out fully, yeah, cairowindow point, but nevertheless, let's find the cairowindow point. Oh, that's hit in one. You see, so cairowindow point is defined as a math point. So I should just use point without the 2 then, and then from cairowindow. The only sad thing is that I already have a point defined, so this point here. Maybe I should rename this point then. Or I can do I can make an abbreviation for cairowindow. Or I can just stop whining and say to hell with it, replace math with cairowindow and be done with it. But yeah, since the only reason I do this is because I don't like this. I mean, what looks better, this line or cairowindow? Or this line. I think auto starts to look better. Can also do auto. Of course, it is probably returned from LinePoint. Or I can just do cairowindow like this. Not totally not confusing with color wood. Color width, but it didn't help. Cairowindow like this. It's not a using then, is it? It's just namespace cwin is cairowindow. I never do this. I just type things in full. It's not even that many places where this happens. And then we have more of those, like here, the direction. So what is cairowindow direction? Oh, amazing. It is equal to math direction 2. So you see it coming. Direction. Direction. And then do we have even more rows? Line piece. Hyperblock, that should stay. Line piece, and line. Line piece and line. Okay, line piece, cairowindow line piece is math. So we can do the line piece as well. Looking for, yep, it is math. That doesn't look good. How can this even compile? So probably comment it out. Yeah, it's commented out. Call type double. What's the last one? And my comments do get effed up by this kind of a search and replace. Oh, I hate that. Yes. I want a formatter that fixes that. There's more of that. I don't know, it looks good. We have a red and green. So no blue lines. Oh shit, blue lines. Yeah, I don't know. I just let my subconscious do the scanning here, and it didn't trigger anything anymore, except the not aligned comments, of course. This coordinate system is it's being nasty. Pim, pim, pim. These probably all got changed. But I want them aligned. Oh, and they are aligned. I want them aligned with 8. Okay, cairowindow to cwin, is that -8 characters? By pure luck. Yeah. Great. I have to go back to the testsuite here. There is no... Oh, there is it here. Hyperblock. I didn't see it. Why? I want stuff to be pasted where the cursor is, not where I click. It's very fast around this time. Feels like I have a half of a data center for myself. It's not a data center anymore, it's more like a supercomputer center. The user moved, what was it? User moved Hyperblock to math. I'll check for naming, case sensitivity, nobody knows why, but and submodel updates. You can't update anything yourself because you don't have it. Oh well, actually it can update. What, I already did that. Offline git submodel update won't work. Actually, it will, because they're just public. And I gave it internet. We need to explore about Hyperblock. It could be in a different... Well, it cannot find it. Oh, it cannot find it. You could try synchronizing with remote. Yeah, it does. Fetches it. Why does it check out something? Just what? No, it's in a detached head for some reason. I need to create a test file and check the distance of an intersection points functionality. Take a closer look at vector index now. All design tests to verify that intersection points returns correct points. Checking distance. Curious if plane distance is defined elsewhere. Well, it's a member function of hyperplane. What else? I wonder if distance is an alias or maybe defined in hyperplane.cxx, so it does not exist because hyperplane is a template. Okay, I was looking for distance in Hyperplane. Could not find it. Where did it see the call to distance? Somewhere here, I guess. This is hyperplane itself, yeah. Hyperplane, signed distance. It does not have a distance. There's no distance. Where does it see distance then? Checking distance. Victor, why is it even looking here? Distance off. Hyperblock. Distance off calls, here it is, calls plane distance, where plane is a hyperplane. Yeah, it is totally right. It just does not exist. Huh? So why this probably compiled because I just never called distance off. You turn the distance from the corner to the hyperplane. Yeah, this is wrong to begin with then. This should be like sine distance or something. Or what? Very confusing. At least now I understand what it is doing here. It's looking for a function that does not exist. I don't see distance. Maybe it's defined elsewhere. When a new file, it keeps looking. Plane isn't defined elsewhere. It keeps looking. Seems like Hyperblock fails to compile due to missing distance. Maybe it's an alias for sign distance in hyperplane.h, but I can't find it. Could be a free function or template affecting this. I should check the last commit for any changes. Distance isn't added yet. Maybe updating or rerunning git to bring up there. Oh boy. Now create tests for corner index and distance off using a computed approach instead of direct access. It seems Hyperblock expects distance, which might require updates to Hyperplane. I'll check for free distance functions and ADL definitions. Div only shows part of the file. Yeah, it's the only place where I changed anything. Look like Hyperplane changed some from struct to class. Adding distance. What? No. Wait, add distance here. Intersection points. Distance off. Nee, this is Hyperblock. This is just Hyperblock. And Hyperplane is only changing to a class. There's no added distance. Need more lines to confirm. The div is cut off. No, it's not cut off. There is nothing else. Git when you see math div blah 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 blah. Seems like Hyperblock uses plain distance, but Hyperplane might lack it. I'll check the latest version. Math hyperplane.h, but since it doesn't compile, I'll focus. It doesn't compile. It compiles for me. I'll focus on testing intersection points as expected. I'll implement a helper to compute expected corner coordinates for, well, that I would be impressed if it is able to, but okay. Corner index and check distances. I'll design test. Oops, it's done. Added a math hyperblock test.cxx with helpers and cases that exercise hyperblock intersections where x is aligned, diagonal, disjoint, vertex touching and sampled planes, mirroring the hyperplane suit style. Registered the new hyperblock executable in the CMake configuration, so it builds with the other math tests. Updated to the math submodule revision that introduces Hyperblock, whose constructor currently leaves the per corner offset vector uninitialized. Issue the new tests no service. This is really weird. It updated the math submodule revision. Well, I already did that and pushed it to GitHub. It's just so failing and syncing with GitHub. And this was a new question. Fails because the Hyperblock constructor's uninitialized corner offsets lead to only 3 intersections being reported for an axis-aligned slice. It did find a bug. Uninitialized corner offsets. Great. Okay. I want to look into the syncing though. So most of the time it just runs, well, it does run the setup script. But the setup script only updates the submodules. It does not update the current project. Do I have to do that myself? That's insane. Nevertheless, so this should not do anything. This shouldn't just stay local. Ish. What's this? Oh no, geomath is just whatever it was. data packages, which is nothing, doing nothing, I hope, except spamming. What? I don't know. New? It's like, come on. That, how are we not using a cache? The documentation says the cache is kept for 12 hours. Well, I used it an hour ago at most. But if you don't have app utils at this point, then it just creates a new container. And then despite creating a new container, apparently, it still has an old checkout. And it doesn't get the head of my repository, apparently. Weird things are going on. This should work. So it adds the super project remote here, and then it says fetch master. This should give me the latest thing. Well, fetch anyway. Fetch makes it available locally. Does not check it out yet. So it downloads it, but we are still stuck on the old commit. I don't know what this means actually. Plus, well, it doesn't print any hashes anyway. But if it sees the latest hash of math, then it also has the latest master of the testsuite. The latest is 659F0. Six 59036. Yep. So it does see that math is updated to this, Therefore, it has the latest AI math testsuite as well. Then it moves work to old work, and then it creates work from fetch head, which might be the old master. I'm not sure. I think origin master is definitely okay, but if that happens after setting fetch head. But yeah, I mean, it just fetched it. Is it like not the latest head of that we got from origin? Well, that succeeded, so now we delete the old work. Remove origin. On branch work, it does not show me the hash. Ref parse head. Should that not show the head then, as it were, of the current thing? To be F2. To be or not to be? It's totally not this one. So is this an old one then? E276B. E276B, yeah, that's very old. Well, that is that it shows remote GitHub master. What? I did not push. Ouch. Did I not push? Of course I pushed. I did not push. Oh my god. Okay, well, we solved the problem. Unbelievable. Yeah, there were. I don't know. I have to ask the AI to do it again. I guess because I also made changes in here. Let's also solve the distance thing then. I wrote this because I wanted to do something with it. I thought I needed it. Is this an absolute value? No, of course not. I think I well, I don't know. I think it's just deleted. Let's change it into sign distance. Makes little sense actually. I would rather get the side, the side that it is on. Maybe I add both. Probably just so we don't have direct access to the corners. So it makes sense to just proxy everything here. Yeah. Do I want to know the height along then as well, or not really? I suppose. Just hesitating to add every member function here again to Hyperplane. Just because I want to keep the corner vector private. Kind of makes more sense to pass that to the hyperplane, in whatever corner. So access the corner and then pass that to the hyperplane, so the SA. So we're not going to call sign distance at all on the plane or pass the plane at all. I'm just going to get the value, I think. By index. Yeah, I might as well make it operator. Should always be const. Hello, Yuyin. Oh, sorry, I already saw you. That was a while ago. Yeah, git commit -a. And what did we change here? Don't can't call member functions on Hyperplane. From Hyperblock, just return the corner. Now we have the following problem. I'm not sure. Actually, I'm pretty sure that it doesn't update this commit if I ask something in the same chat, and I can also not ask it to update it because it can't, because it doesn't have a remote for the super project. Which means that we would lose the stuff that it wrote, and well, that seems a bit cruel. So yeah, I'll have to, I think, do the create PR here and commit that as well, just to keep it. Failed to create PR. Great. Well, I'll just do it manually then. For sure, this one should work. Def null not an index. Stupidity. Yep, did not add it. Well, fortunately we can also copy the patch itself. vi math hyperblock dot patch. And yeah, def null is res dot. The other one is a -b. Source patch -1 p1 patch. Now we have it, so I should be able to compile it even, I think. It's still there. Nope, everything is there now. It paid off. The AI fixed my bug. Took several days to get it to compile in the AI environment. Now we found 10 bugs in the AI environment itself, but maybe for here on out, it's going to be a little bit more productive since I got all this set up and working now. Oh yeah, this is also brilliant. Now you get to see this div. Correct PR? Yeah, I don't think so. Yeah, that's so not useful. But fortunately, we have logs. And in the logs, I think you can see the div. This is Hyperblock.h. I would rather see. I think this is the only line it added. I think there was also a div. Oh yeah, see. So we have to manually edit hyperblock.h. Wasn't a constructor, so I think you. Yeah, or not. It passed, and then the big test 140. Come on, not fine. All that. That's an entirely different project, actually. Did I not? Yeah, okay. Git commit -a. So again, the prediction, and I think correct answer is 140. Yes, it fixed it. Brilliant, brilliant, brilliant. Now, a one-liner it was. The rest I did correct. Just that one line, but it found it like instantly. It's pretty good. Okay. Yeah, yeah, yeah. Just go back to the. My memory has been completely purged with respect to this project. I have to remember what I was working on. Yeah, I think the objective was to draw in cairowindow a tesseract with all kinds of coloring. And the interruption was for moving hyperplane and hyperblock into mouth. I think that work was done in Hypercube, or should be done there. Yes, this is where I was working. So the objective here is to generate a test rack, and then draw it in the cairowindow. And I have an example that gives a little bit an idea where to go to. Well, that's a normal cube. This one. This is a test rack. So we want to end up with something like this. And then once I have this, I can add all kinds of coloring to it. And we can add points to each edge, which I can grab with the mouse and slide back and forward, which then should interactively do everything. I might even be interested in being able to rotate the thing. It shouldn't be too hard. Could just add 4 sliders or something like that, or how many sliders I need to rotate around each of the 4 axes. Can at least look at the thing from different sides if that is needed. Okay, so yeah, let me just start with opening a cairowindow and having a number of sliders, which then gives me the corners. I think that the sliders give me the direction of the hyperplane. Let's make the window. The window is the hyperplane, and then we rotate the hypercube. But the hypercube has its own coordinate system in 0 or 1. So then the sliders determine the normal in that space of the hyperplane. So I could do, let's say, yeah, how to update a 4-dimensional vector, a 4-dimensional unit vector, rather. With how many sliders would I need? 3, right? I think ChatGPT knows that. It's an extension of the normal what is the word? I can't find words. Okay, the polar coordinates. Yeah. With what extension of the polar coordinates in 3D can I define the direction of a 4D unit vector? Using hyperspherical coordinates, aka 4D spherical coordinates. The unit vector u, element of R4, so u is an element of S3, is determined by 3 angles. One common convention matching the 3D spherical pattern is we have alpha, beta, and gamma. So I need 3 sliders where a and b goes between 0 and pi and gamma between 0 and 2 pi. And the rest will follow. Okay. I need to create a new Cairo window. Let's see, where do I have Cairo window tests here? Probably only in Cairo window itself. Cairo window / tests. Pick a good one. Well, it's gonna be something with a slider in it, and I bet that is called slider. Something slider. So which one do have sliders? A lot of them. Shortest arc length, scale length, quadratic Bezier, parabolic fit, cubic Bezier, clamp check, arc length. Yeah, jump. That's not even that much. Here's something with pi. Slide face. Okay, I'm going to use this one. And then, of course, hypercubes, right? Hypercube. Yep. Okay. Well, let's begin at the top. Gradient descent, Cairo window. I probably need all of these. Maybe symbolic as well, I don't know. Probably need thread. You need this as well to print the exception. Oh. Define use sliders. Okay. Main, entering main. Well, let's see, that would be for random numbers. We don't have random numbers, I think. Try. Namespace Cairo window. Maybe not. Okay, create window. Background layer, second layer. Got the whole thing. curve. We have sliders which continue all the way up till, well, I don't know, sliders. Let's say one slider. Let's do this slider face and the label. But I need multiple, and I'm just gonna explode the whole thing into 3 sliders immediately. Let me first finish this try loop. I think this ends with the window close. That should be it. Do I not have AI alert as a header then? Yeah, probably should need that as well. We don't have that. This is called Hypercube. I might as well call it tesseract actually. Yeah. That's a big window. Why is it this big? And why is it not saying 1200 times 900? Okay, create slider. How does that work? Create slider takes a rectangle and the start value, and then a minimum and a maximum value. The minimum value is 0 and pi. Slider alpha. Slider alpha label. Let's use text. I don't know. We're gonna do alpha, beta, and gamma. This one was 2 pi, and this one is also pi. Also from 0. And this also from 0. And well, the starting values. Let's put this one at 0. And this one. Let's put everything at 0. Nah, that won't work. Need to see something. It's 1.0. Okay, and then this just reads the values from the sliders. I'm not drawing any sliders yet, I think. Is that automatically drawing? Yes, I wrote the code. No, I have no idea how it works anymore. Yeah, the sliders are not mentioned anymore. So I guess this is enough. Create slider and bang. Oh, damn it, it creates it on the plot. What? I don't have a plot. I don't want a plot. Just want to draw stuff. Plot create slider. Yeah. What is that doing? It creates a slider and then a draw object. Do I have a plot slider object? Plot class, plot, namespace, plot, slider plot, yep. But we don't want a plot, so I think the only thing I need is this shared pointer, the draw slider. Which is returned by whoever assigns to draw object, which is here. If we do something like this, that should work. And then we do a static cast draw regions on. Okay, yeah, well, we still have to draw it. This creates a plot slider, and then I'm setting the draw object on that. And then the draw object is being cast to a multi-region, and we call draw regions on that. And then I get a window. Oh yeah, register draggable. Basically I have to do everything except to create a plot slider. Just copy all of this. Copy. Mangle it to something else. But I need to do that 3 times. So how about I just remove the create slider. So if I remove the plot. Because I don't have a plot. I'm editing the wrong file. Substitute plot dot with nothing. No more plot. Create slider is needed. add a create slider here. Plop. That is create slider, except that it isn't. Create slider. Try to get the whole function. Also add text. It's like right there. Yep. Yep. No. No plot. Plot text. Wait a minute, that's not what I want. I think I copied the wrong one. Anyway, this one should be the good one. Should it not? Yeah, this should be the good one. So we remove plot here. And remove plot and hope for the best. I wanna have the add text first, so. Is it even add text? Yeah, I need create text. That's the problem. Create text. Create equals add text, but never mind that. It's just not a draggable. This is a member function of plots. Yeah, okay, so let's copy this one. And then turn this back into the add text because it turned out we needed it. I understand about as much about of this as whoever is still watching. But that's what coding is, isn't it? Just do something until it works. No, seriously. Let's first do one of them, because well, let's first do the interface. So just comment this out. And then one compile, so I do a return empty slider if that works. And then here the same thing. And then this might not compile, so let's comment that out as well. And then look for create, and then we see that, yeah, create slider and create text is being called. Cairowindow text. Cairowindow text. Cairowindow layer maybe. Cairowindow everything. It's kind of strange to add cairowindow text here while there is already a cairowindow point there. It's probably not cairowindow, therefore. Where is my create text again? Create text is here. Which namespace is this in? Namespace. In plot. Grrr. That's no fun. Oh, of course, it returns something that I don't want to return. This returns a plot text, but I don't want that. So let's return something else. Let's return a draw. Let's return a draw text because I don't know. It has to exist. Am I doing some using stuff here? See, yeah, using namespace cairowindow. Yeah, I'm just gonna put it at the top. Cannot create a draw text like that. Stop complaining. This is draw text. That needs all that stuff. Style text. Pos X. That would be, I guess, position. Dot X maybe. Position dot Y. The text style. That was it. Yep, that was it. Slider, same problem. The draw slider takes this is plot slider. This is draw slider. That takes these things. Yeah, it's just exactly these coordinates, exactly these things. No matching function called to create text. No known conversion from pixel to point. Then what is a pixel? Oh, I think it's just a point, but then in pixel coordinates. Coordinates of a point in pixels. Okay. We cannot create a point from pixels. I mean, this thing takes a point. That should be a draw point. Oh, it just says point. Yeah, I think I have to use draw point here. Was it that I copied it from the namespace draw? In fact, there should be maybe draw a rectangle if that exists. Let's see, this is cairowindow point, this is plot points. Or I copied it from plot, didn't I not? No, I'm not too sure anymore. Draw point, no, this thing even takes only X and Y. That's definitely not it. I think it was loads of points. At least I have a point. If you get my point. I think that it was a cairowindow point. I just removed the cairowindow. Yeah, I remember now. And that is a math point. So a math point, since when can a math point be constructed from pixel? Doesn't make any sense. Math point, I can type. Oh, well, like this. Series of doubles, I think. Create text taking a pixel. Copy the wrong one. Hey, I probably should link with cairowindow. I probably should not be a complete idiot. What is it bubbling? Error at target link libraries. The keyword signature for target link libraries has already been used with the target hypercube. Excusez-moi, I added it to the wrong place. Not even sure if symbolic is needed. Not even sure if math is needed. Let's hope it is. Typing for symbolic is symbol totally needed. I had a feeling. I just wanted to be sure. Symbolic. Link damage. Okay, add links. Next step, let's draw the text because that seems the simplest one. So this is the plot text, which I do not want to create. And therefore also not return. What I want to return is whatever add text is creating. No, add text is creating something. Actually, it's a void. And this one takes plot text. Okay. Yeah, and then it writes that, which in the end I want to return. You also need that, and we need that. No, this just this text is gotten from there. So we created with position and text, and then we get that back here, position and text. So I already have it, like in this thing, it's just position text is just whatever it is. I don't return anything, and this thing here, let's do that in line then. So I don't have to call it anymore. And we can delete this. And then the position, we already have position. And text is, we already have text. And this is then what I want to return. Let's call that a draw object. And let's call that auto. And then I have, well, we do this, which is the same as that, so we don't need this anymore. And then we call draw layer region on, passing the layer, which I have. And then the draw object, which is now simply this object here, draw object. You need to keep the draw object alive, so I cannot return a draw text, which is nonsensical. Unless I can. I mean, you can allocate it on the heap. Or I can just return a draw text, why not, as object. Same thing, right? So unless this text in draw really demands to be on the heap for some reason. That is this thing. Layer region. Virtual to draw. I don't think it matters where it is. Seems very unlikely that it matters where it is, where you put it. To draw. Just have to keep the object alive. So instead of creating it with make shared, I might as well just create it on draw text. And then this is not an object, it's draw text. And then we just create it instead of using make shared. And then the draw text, oh, draw region on maybe takes a shared pointer. Yep, send it shared. Okay, in that case, that must be a shared pointer. Yep. And yeah, then we have to keep it alive, so I just return that. And then this must be a standard shared pointer. And then this is a standard shared pointer, which is then kept alive until we close the window. Which is a bit harsh, because then I can't inspect it. So maybe I should wait here a little bit. Or just not close the window. Let's see if this works. Oh, the draw layer on. Yeah. That is a member function of cairowindow printable. Nice. Nobody knows what it is then. Don't tell me that is a member function of plot. Or plot is derived from printable. Plot, class plot, totally derived from printable. Printable has our service, cairo context, and that's the only thing. I think it's only called printable because it can print to my printer. I'm not really interested in that. Create service with a file name. Seriously? No, that's the default constructor. But we need to call this then. You have to be kidding me. Yeah, no way. What? Oh, you see what it does. It just uses the layer and then also handles printing. But I'm not interested in printing, so we might as well call that directly. So what you have to do is inspect what this thing is doing. If need, oh shit. Sometimes I'm really wasting time. If need print, no. Layer draw, need, no. Okay, so we just need to do this. Call draw with a layer region on layer. That's the only thing that needs to be done here. Now I have my layer and I call draw, and we have a layer region, which is the draw object. Which then this draw on layer better uses also a shared pointer. So this is cairowindow layer. Cairowindow layer, that's here. And that has a draw, and that takes a shared pointer. Okay, and then over layer region, that means that my text, the draw text, must be derived from a layer region, which of course it is. We go to draw here, and yep, that is a layer region. Everything comes together. Now it should compile, and not only that, it should draw labels, 3 of them. Hypercube. Alpha, beta, gamma. It sort of works, but they're a bit close together, and this one is strangely higher than the others. Very strangely higher. Can even close the window. Beautiful. Okay, maybe replace the text with something else. The gamma is so big. Or I can make them just big, smaller. Let's make them smaller instead. Slider style. Slider style is here. 12 points, maybe 12 points. Center below. I don't see any reason why it would be higher. Why would that gamma be higher than the others? It's still higher. But why? Is it the text? Is it something else? If it is the text, then I change gamma with beta, and it should definitely be the same as the other beta. And it is. Now it is the same. Is it? Yeah, I think so. Okay, so there is a bug in my text stuff. What is the centered, I think? Maybe the centered is a problem. No, the centered below is horizontally centered. Not centered with respect to the... Maybe centered, no bearing. I'm just guessing, but it has to do something with the bearing. There we are. Yeah, there was no bearing. Cool. Let's add a slider. It themselves. The other one calls create slider, and you have to return very likely a shared pointer. to draw slider. And you have to very likely do almost the same thing, right? So just create a, so get some syntax outlining here. I don't want to do this. I want to create a draw object. And I have geometry, and I have start value and minimax value, so that should work. Static cast draw object to a multi-region. Well, okay, if you say so. Except that this is like that. Dots draw regions on layer get. Well, okay. Oh, that's because we have to register it as a draggable. Okay, we get the window from the layer, then we get the shared pointer slider thing from the draw object. Well, I already have that. Like literally here. Let's call the draw object the draw slider. Here's the slider pointer, now it's called draw slider. And then we register the thing with the, oops, this pointer. And then this is the slider, oops, the draw slider. Get draw slider. Cairowindow point. Returning a point, return point. Oh, that's this point here. Okay. Why am I fetching draw slider? Nobody understands that. Oh, to keep it alive. Yeah, okay. It's a shared pointer, so we have to keep it alive. Yeah. But this pointer is a problem, of course. And then we don't return the plot slider, but we return the draw slider. And this should look very much the same as that, and it is because I copied it from there. So that's about it, except that, what do I have to pass to register drawable? Batch window. Or plot. It wants a plot. Window register drawable. Clickable rectangles. Draggable geometry. Clickable plots. Pushback plot. Why is this needed? Plot dot register draggable. Shit, I need a plot. No comments, dragging. Yeah, this is just the list of rectangles that if you click in one of these rectangles with the mouse, then something is going on. And well, with clickable index. And then the clickable index is probably used to get the plot pointer. And then we're going to use the plot pointer. Ugh, but I don't want that. This is window. My window is way too using plots too much. And then register the draggable on the plot even. Why? Draggable pointer, standard function. Draggable, set index, draggable restriction. Update grabbed. Is that maybe who's using draggables? Probably this class, because it's a private something, private member of this class. Draggable pointer. Yeah. Draggables are just being added here, and then we have a .cxx file which update grabbed. Draggable new position. Draggable convert. Question mark. Do we have to convert it or not? Convert from pixel, otherwise use the point. Draggable restrictions. If that exists, then call it. And then call moved on the draggable. And then return the geometry of the draggable. Basically, we want to know who is calling update grabbed, because that is the criminal here. Oh, this one. This is doing it. Window update grabbed runs over all clickable plots and then calls update grabbed. So that this window function is getting an X and Y coordinate. Probably mouse XY coordinates. But it already knows what a clickable index is as well. I can still live with all this if I know who is calling window update grabbed. What's probably happening there? Yeah. Input event drag. Grab index. And how do we get grab index? Grab index is set here at the button press. Index. Index is grab draggable. Grab draggable is a window thing that is using clickable rectangles. Hopefully only clickable rectangles. By the looks of it, yes. So I can hijack all this, provided an update grab is a virtual function. in window, and if not, then I'll make it. It's totally not virtual. Stupidity. Who thought of this? Hey, now it is virtual. I'm not super happy with it though. So another way to make this independent from plot. I'm eating salt. Because I needed salt. I have too much salt. I need to get rid of the salt again. Okay, let's not make it virtual. Let's fix it another way. So at some point this function is being called. No, not yet. Well, actually it is. I'm just abusing a plot object here. I could just create a random plot object, I think. I mean, who cares? Just create an object and then abuse it for these vectors. I think that should work actually. Needs a few stuffs here, but yeah, hopefully it's not automatically drawing it, or what do you think? Nah, not. It's not doing anything. Can't I use this thing? Let's try that. I'm just gonna make a plot object that I'm not using, otherwise it gets too complicated right now. as a default constructed geometry. Should not be used, right? And what was the other thing? Plot style, plot area style. It would also have default values. Cross fingers. That's already there. Oh, it's defined in namespace plot. Plot. Do. Ugh, code dump. Oh, it's an assertion. Rectangles must have a size. Well, not be uninitialized. To put it that way. I just pass the window rectangle. Surely that has a window. The window has a region. Or a geometry or something like that. Window. Cairowindow, window. Where are we? In plot? No, this is cairowindow, window. Yep. And then I want to have some kind of rectangle thing. Geometry. We have sliders. We cannot move them. Shit. I was afraid of that. Oh, wait a minute. No. We cannot move them because we don't have a loop. Yeah, I need a loop for that. Not sure anymore how that works, and I have no idea why it says 1. Oh, it says 1 because I put them all on 1. So this is 0 and this is 2 pi and these two are pi and they are on 1. So this is half it, that one. Everything is okay. I just can't not move them yet. Okay, let me think. Loop. I was copying stuff from... something, a slider. Hopefully. No. Well. Ah, this. That is what you need. And that's done at the end. Phantom. I'm going to write I'm writing a program to draw tesseract on cairowindow window. And in order to rotate the tesseract, I need three sliders, so I'm adding those now. I think this is the loop. So you could add an infinite loop for now. That has this in it. And then probably close the window if we ever would escape that loop. But for now, this is a forever loop. We suppress all the window updates and then we do stuff like reading sliders and updating stuff. This is actually going to do the drawing. Well, let's print a few values. Let's say I'm just printing all the values. Hey, that would be nice. Alpha is slider alpha value. And beta is slider beta value. And gamma is slider gamma value. And then we don't do nothing. And then we block until the program must be terminated, which is doing a break. And this is not needed, I think. And then, yeah, wow. If this compiles, it's gonna work. We know it, and it does not compile. But compiles almost. No member named value instantiated stuff. Okay, let's make it a pointer. Let's make it a pointer. It is a pointer. Let's use an arrow. And still it doesn't want to compile. No member named value in cairowindow slider. Ridiculous. Of course it has a... Come on. Where's my slider definition? Auto. Create slider. Oh god. It is, of course, the problem is that plot has a value. Plot has a value, but I'm not using, well, namespace plot anyway. And now I'm including that anyway, which I already was. Maybe I should have used plot slide. Arg. Don't tell me I should have done that. Well, we can still add this, of course, and then just do that. But yeah, starting to think I should have used this, and then suddenly everything comes together, and you can undo everything I did in the last half hour and just continue using my fake plot to do everything, including adding the slider. This is highly annoying, isn't it? Are you serious? Yeah, I was like, yeah, I don't want to use a plot. And then in the end I had to use a plot anyway. And now it turns out that that was the best way to go all along. Use a fake plot. Still highly annoying though. Yeah, now the fake plot is already here. Don't need to pause that anymore. And now it's a dot. Isn't it maddening? Move. Yes. So this moves now between 0, as you can see at the top here, and pi. That's is pi. Isn't it amazing? It's also printing all the values, so you can move this to 2 pi or 0. This one, well, everything works. We have 3 sliders. Isn't that half the work, like? Well, maybe even more than half the work. So now I can calculate my normal vector like that, apparently. Inverse stable via a arctans 2. Yeah, we want to do the inverse. I don't want to do the inverse, I think. Let's just calculate these things which are, yeah, I'm gonna call them mine the hyperplane normal. Let's just create a normal directly. I want to play a normal, which is a vector, and as far as I know, just a math vector. And well, a 4-dimensional math vector, which I should be able to construct from 4 things that are convertible to doubles, like or already doubles, like cosine alpha followed by the sine alpha times cosine beta and then sine times cosine and sine gamma. Bleep. Okay, so this should be a normal, well, it is a 4-dimensional vector, and yeah, it has a length 1, as you can see. If you put this thing at 0, it points in the x direction. Okay, if I put it at the top, negative x direction. I'll put this at 0, it's pointing, I don't know, somewhere on that. I think it's pretty much rotating around, yeah. It's not very clear how, but as soon as it is visualized, I'm sure you see what it is doing. Or not, because it's a 4-dimensional vector. But okay. Yeah, so next step, we have a normal. Now we can create a hyperplane. I mean, why not? Math hyperplane. The hyperplane is created from a normal and B. Normal, comma, yeah. Actually, we need another slider, I think. No, we don't, because I want to use an orthogonal projection, so it doesn't really matter. Well, if I want to cut the hyperplane, then we want to move the hyperplane through the tesseract and then see where it, well, maybe I do want to do that, yeah. For the orthogonal projection, it's not needed, but it would be nice to actually do the cut and then just see well, see, draw the points where the hyperplane is cutting through the edges. Yeah, that's pretty cool, I think. So let's make a force slider that allows me to move the tesseract through the hyperplane. And that would be something that has to change between, let me think. The point in the hyperplane is then the longest distance is the diagonal of this hypercube of the tesseract is 2, I think. It's 1 by 1 by 1 by 1. So all squared, still ones added, 4 square root 2. And the one corner is all zeros and the other corner is all ones. And the diagonal between that has length 2. So I think we can just make a slider that changes between 0 and 2. And then move the hyperplane along that long diagonal, maybe. It would make more sense actually. I think less confusing. I think if we would move it along in the direction of the normal itself. So I guess I could use the center of the hypercube and then go, say, -2 in either direction, in the direction of the normal. So let's define the center of the hypercube, which is of course also a vector. It's also a point. Is it a point or a vector? I'm going to use a point. Let's call it center. The center of the hypercube is at 0.5 because the corners are 0 or 1. And that is very, very fixed. So let's make it const. And then I need another slider, which we'll call offset. Auto slider offset is fake plot create stuff, and this one moves from -1 to 1, which that is a length of 2. -1 to +1, and we start at 0. That is in the center. And then that is obviously, well, what is the difference between those things? 50. So that would be 1, 2. Yep, and then we have it. We have it. Then you need a label, slider offset. Label is create text, slider style, pixel, I guess that's the same coordinates as here. Comma, offsets, like that. Oh, should be good. This is so const, I'm gonna put it outside the loop. Okay, I want to move my point. Therefore, I need to add something to it, which is I can only add a vector to my point. So we make a vector, a 4-dimensional vector called offset. But no, it's I already used offset. It's totally offset. Let's rename this one. Off. Ah, come on. Slider offsets. Offset value. So let's make a point then that is in the hyperplane. I'm gonna call it P because I call it P all over the place in my comments, and that is then the center of the tesseract plus this offset. And then here we can do minus n times p, because that's how you create a hyperplane. I'm not sure if that works, so let's put parentheses around it. We can do minus the scalar. N times p should be the dot product, and if it's not, then it's probably not, is it? Let's see if hyperplane. So actually, that's a vector. If my vector defines a dot product as math vector. What do we have here? Eigen dots. Here I have a dot. It's unlikely I have a operator star defined with a thing. Multiply with the scalar. Length, vector, vector, point, vector, vector. It's an addition. Nope, it's a dot. Oops, what am I doing? This is the scalar. Yeah. Let's do p dot n because it's the same thing. Now we should have the correct hyperplane. So next we need to run over all the corners of, well, wait a minute, I first need to create my hypercube, but the hypercube is totally the hypercube doesn't move, so we can put that here. The hyperblock, 4-dimensional hyperblock, but it's gonna be a cube, a tesseract, whatever. Tesseract. The hyperblock is created from two vector types, namely the origin and I'm just creating it like this, I think. So 0, 0, 0, comma 1, 1, 1, 1. Can also be const. I think this is where I'm going to check if it still compiles. No member name dot in math point. Okay. That's all nice and dandy that I created a point, but it cannot do the dot product then. So let's make it a vector. It probably also won't work. Oh well, forget the point. Everything is a vector. It's called normal here instead of n. Okay, we're still compiling. Well, git status, and I'm modified, really? Yeah, I want to rename it. I just want to rename it. Oh, I have other .cpps here. Yeah, okay, I'll just keep cpp then. Okay, let's run over all corners. So that would be a corner index. I'm just gonna, wait a minute, I have to call this something. I'll call it Hyperplane. Why did this compile? What the? That is compile. I'm just, wait a minute, I don't even need that. We need a tesseract. I'm just gonna add to the tesseract begin and end, and that will run over the corners then. And it's past 3 AM, so I'm gonna make this short and just not even finish it. I'm sorry. No graphics today. Well, maybe later today after I slept. Yeah, only 2 viewers. Yeah, let's say begin and end runs over all the corners because I'm adding it and it's gonna return a corner index, or rather it's gonna return an iterator. Let me see how to do that. Kind of no, I don't want to. Begin end nonsense. I begin, I mean. So I begin returns index type, obviously. So that is just a corner index then. Return c dot I begin. And I end, turns I end. And then I had tesseract CI. And that did return, that's this one, that returns the vector type. The vector type is a math vector 4. S is everything. I suppose it is returning it by a reference or something. Yeah, it's a const reference. Not that the vector is very huge, it's just 4 dimensions, but hey, it's 4 doubles. Don't want to burn out my CPU. Oh yes, we have the corner and we're looping over it. And now we want the corner to be projected onto the hyperplane. So that gives us a new vector. I suddenly realized that my hyperplane is 3-dimensional and my window is 2-dimensional. I need another direction. I need another projection out of nowhere. Well, that's probably easy. We just lose one of the dimensions of the hyperplane. The fixed dimension, I think. Doesn't really matter. Does it? I'm not so sure, actually. Anyway, so far so good. We have the following. I want to project it, right? So everything is a vector, a 4-dimensional vector still. Do I even want to project it? I want to visualize it. Yeah, the thing is that I said in the beginning my hyperplane is parallel to the screen. And the reason for that was that I thought that would be, you know, more intuitive. But it's the hyperplane is 3-dimensional, so what the F? Feels like I need more sliders. The 3 sliders that I have now rotate the hyperplane relative to the tesseract. And then I can definitely, well, I need to lose 2 dimensions. And one of the dimensions is it is probably intuitive to lose the direction along the normal. So I'm going to project first onto the hyperplane. Yes, let's begin with that. But then I still need to lose another dimension before I can even start to think about drawing anything. How do I do this anyway? So this is okay. So this is we call this the hyperplane. So you lose the plane, the hyper. I mean, nah, nah. No, let's not lose it, because it might be slightly confusing, because you also have real planes, as in the window. This is the hyperplane projection. I think the hyperplane has a dot project a corner on the hyperplane. To check if this is the case, hyperplane projects orthogonal projection of A onto the hyperplane. Yes, totally. So now we need another direction to lose, as it were. I have to go to bed. I'm just gonna go to bed because, yeah. I guess I just need some vector that is orthogonal to the normal. Then we can project along that vector, and then what is left, you can still rotate that, actually. That would be then just a normal rotation in the window, so not really important. I can just keep adding sliders, you know, as many sliders as we need. Why not? Maybe we should do that. So I have 3 sliders to position the hyperplane relative to the test rack, and then another 2 sliders to position the hyperplane relative to the window, I guess. And then everything is defined. Yes. And then after projecting it and rotating it and blah blah blah, and we have finally every corner converted to window coordinates. I can just draw the tesseract. I mean, I can draw a little circle at every point and draw lines between every pair of corners that form an edge. And then you have this image. Except then I can rotate it in 4 dimensions and everything. And then the nice part starts, because we can also show all the intersection points on all the edges of the hyperplane with the tesseract. And then you can add all kinds of beautiful coloring. I mean, it almost becomes easy after that. We are basically almost there, I think. Yeah,